Most of us learn that the sun is a giant ball of gas, a blazing sphere that has burned for billions of years, dominating our solar system with its immense heat and light. Deep within its core, the sun is said to burn through nuclear fusion, a process where unimaginable pressures and temperatures force hydrogen atoms to fuse together. This fusion transforms hydrogen into helium, releasing vast amounts of energy that radiate outward, eventually escaping as the sunlight and warmth that make life on Earth possible. It's a powerful image, rooted in the language of nuclear physics and mathematics, and it has shaped our understanding of astronomy for nearly a century, guiding generations of scientists. But there's another story, a radically different way to see our star, one that challenges the very foundation of what we think we know. Imagine the sun not as a self-contained furnace, but as a glowing node in a vast cosmic circuit, its energy shaped by forces that stretch far beyond our solar system. This is the core of the electric universe, an idea where the sun's energy comes from immense electric currents flowing through the fabric of space, converging on our star from the galaxy itself. This model challenges the foundations of modern astrophysics, asking us to rethink the very forces that shape the cosmos and sparking passionate debate among scientists worldwide. The Standard Model, for all its strengths, still struggles to explain enduring mysteries like the sun's superhot corona, a region far hotter than the surface below. And then there's the nature of solar flares, sudden violent eruptions that release more energy in minutes than humanity has used in its entire history. The electric model suggests these phenomena are exactly what we'd expect from a massive electrical discharge, as if the sun were a gigantic, sparking dynamo. In this view, the sun is a dynamic electrical entity, constantly interacting with the galaxy, exchanging plasma and energy with its cosmic environment. This isn't a minor tweak to our understanding. It's a new paradigm, a shift that could transform how we see not just the sun, but the universe itself. Thinking electrically connects the sun directly to the galaxy, making it part of a galactic-scale power grid, where energy flows across unimaginable distances. The sun becomes both a receiver and a transmitter of energy, not an isolated object, but a vital link in a cosmic network. This perspective opens up new possibilities for understanding all stars, suggesting that every star may be part of this vast, interconnected web. It invites us to see the universe as a unified, electrically active whole, where galaxies, stars, and planets are all connected by invisible threads of energy. The story of the sun may be far more electrifying, mysterious, and interconnected than we ever imagined, inviting us to look up and wonder anew. The electric universe proposes a radical shift in how we see the cosmos, suggesting that space is not empty, but filled with plasma, the fourth state of matter, made of charged particles that move freely. This plasma fills the vast reaches between stars and galaxies, creating an invisible but dynamic medium that shapes the universe in ways we are only beginning to understand. Plasma conducts electricity, forming the foundation for cosmic electric currents that flow through the universe. These currents are not just theoretical, they have been observed in laboratory experiments and in space, revealing a hidden electrical architecture. If space is a conductive medium, electric currents can flow across vast distances, forming circuits on a galactic scale. These immense currents weave through the cosmos, connecting celestial bodies in ways that challenge traditional models. Stars, galaxies, and nebulae become components in this cosmic electrical network, each playing a role in the grand circuit of the universe. In this view, the sun isn't a self-powered campfire burning in isolation, but a transformer drawing energy from the galaxy itself, tapping into the vast electrical currents that flow through space. Energy flows along immense plasma filaments, powering stars like our sun and linking them to the broader galactic environment. These filaments act as cosmic highways for electrical energy. The sun's photosphere acts as an anode, a positively charged terminal in a cosmic discharge where electrical energy is received and transformed into the light and heat we experience on Earth. The energy comes from outside, not deep within, challenging the conventional idea that the sun's power is generated solely by nuclear fusion at its core. This perspective explains why the sun's surface features, like sunspots and granules, so closely resemble electrical discharge patterns seen in plasma laboratories here on Earth. The similarities are striking and suggest a common underlying process. The cosmic circuit redefines our place in the universe, suggesting a deep interconnectedness between all things. We are part of a vast living network that stretches across the cosmos. While gravity is the mainstream's primary force, electricity is vastly more powerful, capable of shaping matter, moving entire galaxies, and lighting up the universe in spectacular displays. If electric currents shape galaxies and stars, the universe is alive with electrical activity, constantly changing and evolving as energy flows through its cosmic circuits. The sun becomes a junction in the galactic power grid, not just a distant nuclear reaction, but an active participant in a much larger system of energy exchange. It's a dynamic part of a much larger system, constantly interacting with its environment and the galaxy as a whole. This transforms the sun from a solitary object into a participant in a grand cosmic dance of electricity, where every star and planet plays a role. The night sky becomes a tapestry of interconnected, electrically active wonders, inviting us to see the universe not as a collection of isolated objects, but as a vibrant, unified whole. To see how electricity could power the sun, we need to understand Birkeland currents. These are cosmic-scale electric currents that flow along magnetic field lines in plasma, first predicted by Birkeland. Space probes have confirmed their existence throughout our solar system. Birkeland currents are filamentary rope-like plasma structures that can stretch across millions of light-years. We see their evidence in nebulae and the spiral arms of galaxies, visible pathways of cosmic electricity. When these currents intersect, they create a Z-pinch, concentrating energy and forming stars. The sun sits within such a Z-pinch, powered by galactic Birkeland currents. This model explains why stars often form in filaments, pearls on a cosmic necklace. The sun's brilliance is the visible effect of these hidden cosmic wires. The sun's behavior offers compelling evidence for the electric model, a theory that challenges conventional views of how stars function. The corona, the sun's outer atmosphere, is millions of degrees hotter than its surface, a puzzle for the standard model which struggles to explain this temperature inversion. The electric model explains this simply. The corona is a plasma sheath under intense electrical stress, just as seen in laboratory discharges, where energy is transferred efficiently through electric fields. Solar flares and coronal mass ejections are viewed as massive electrical discharges, cosmic lightning strikes, releasing stored electromagnetic energy in sudden dramatic bursts. The sun's granular surface and sunspots resemble patterns from plasma experiments, where electric currents are concentrated or weakened, creating visible changes in the plasma's appearance. Sunspots are cooler, darker regions where the electrical discharge is weaker, and the flow of energy is temporarily reduced. All these dynamic phenomena are natural for a star powered by external cosmic currents, which constantly interact with the sun and drive its ever-changing activity. The electric model unifies these observations under one principle: the sun is a living electrical system shaped by the flow of cosmic electricity. Its most puzzling features become expected outcomes of plasma physics, making sense of mysteries that have long challenged astronomers. The sun's activity is not just nuclear, it's electrical at its core, with electric currents shaping its surface and atmosphere. This perspective could revolutionize our understanding of stellar behavior, opening new possibilities for how we study and interpret the universe. The electric universe isn't just theory, it's being tested. The Sapphire project built a plasma chamber to replicate the sun's atmosphere using electricity alone. Their anode sphere glowed, forming plasma sheaths and temperature layers mirroring the sun's corona. They observed plasma tufts, solar flare-like events, and even a solar wind analog. Remarkably, new elements appeared, hinting at surface nuclear transmutations. Sapphire's results show that plasma physics can reproduce key solar phenomena, suggesting electricity's role in the sun's behavior. Across cultures, the sun was worshipped as a deity. But what did ancient people actually see? The electric universe suggests the sky once blazed with intense electrical activity. Myths of thunderbolt-wielding gods and strange petroglyphs may be records of real plasma discharges in the ancient sky. These carvings resemble high-energy plasma shapes seen in labs. The sun may have once appeared as a dynamic electrified figure surrounded by cosmic flares. Ancient observatories and myths could be memories of a sky alive with electrical power. The gods were not just metaphors, they were descriptions of celestial events. Our ancestors may have witnessed a universe far more electrifying than we do today. The electric universe is not accepted by mainstream science. The standard model, built on nuclear fusion and gravity, is a cornerstone of astrophysics. Critics argue there's no direct evidence for galactic-scale Birkeland currents or a clear source for such power. The electric model's mathematics are less developed, and it doesn't explain solar neutrino observations. The standard model's predictions, including neutrino counts, have been confirmed by experiments. As a result, the electric universe remains a fringe theory, rarely discussed in academia. Science relies on consensus, and new ideas must outperform established models to gain acceptance. For now, the electric sun is an outsider, but every paradigm was once a radical idea. Science is a journey of questioning, not a set of unchanging facts. History's greatest breakthroughs came from challenging consensus: Copernicus, Galileo, Einstein. Our current theories are not final truths. They're our best explanations so far. The electric universe, right or wrong, forces us to re-examine assumptions and look at data anew. We should ask, what's the evidence? What doesn't fit? Are there alternatives? Critical thinking, not memorization, drives progress. The controversy itself is healthy. It shows our knowledge is still evolving. New ideas push us to gather more data and think creatively. An open mind is the key to discovering the universe's true mysteries. We stand at a thrilling moment in cosmic exploration. Despite our advances, the universe keeps surprising us. The debate between the nuclear and electric sun shows how much we still have to learn. The final answer may blend both models, revealing a universe shaped by multiple forces. The most important thing is to keep asking questions and following the evidence. Let's look at the sun with renewed wonder, as a gateway to deeper understanding. Is it an isolated furnace, or a node in a galactic web? The greatest discoveries are still ahead. The journey continues, and the cosmos awaits.